We are discussing again the Euclidean geometry of the May June 2023 paper. In the diagram, we have triangle RDS. A, B, and C are points on RD. RS and DS. RS and DS. Respectively, such that AB is parallel to DS. AB is parallel to DS. And RB is the ratio of RB to BS. The ratio of RB to BS is 5:3. The ratio of RB to BS is 5:3. DC is 20 units. DC is 20 units. And CS is 12 units. You can see CS is 12 and this is 20. But also they've said things like your AB is parallel to DS. Here's your AB parallel to DS. Proof giving reasons that BC is parallel to AD. BC is parallel to AD. Okay, let's prove that one. Let's write the proof. Right, to write the proof that BC is parallel to AD. We'll start by saying so here you'll be having like DC. You can write the ratio of DC to CS. Right, if you write the ratio of DC to CS, and this ratio of DC to CS is 20 out of 12. And 20 out of 12 is equal to what? You're doing DC to CS, and therefore you divide by 4, which is 5 out of 3. And you also have DC out of CS. The ratio of DC to CS is equal to RB. RB to BS. Okay, so the ratio of DC to CS is equal to RB to BS. Because the ratio of RB to BS is 5:3. And the ratio of DC to CS is 5:3. So these ratios are equal because they're both 5:3. So if this is the case, the conclusion therefore is that BC is parallel to DR. Is that BC is parallel to DR. BC is parallel to DR because the ratio of these to these is equal to the ratio of that to that. And this conclusion about the parallel line segments is due to the converse. The converse line parallel one side of triangle O, or sides in the same proportion. In the same proportion. Converse line parallel to one side of triangle. The converse of the theorem that says line parallel to one side of a triangle, or the sides in the same proportion. Sides in the same proportion. And the conclusion, therefore, at this point is that BC is therefore parallel to AD. The conclusion, therefore, is that BC is therefore parallel to AD, because these are lines. They are line segments. If it is further given that RD is 48 units, if it is further given that RD is 48 units, so you have RD like this. If it is further given that RD is 48 units, calculate with reasons the value of the ratio AD to AB. AD to AB. AD to AB. Right, so if you look at these now, the ratio of AD to AB. AD to AB. First, we make the observation that AR, the ratio of AR to AD. AR over AD is equal to RB over BS. So here we make the observation that AR over AD is equal to RB over BS. The reason for this is that line parallel one side of triangle. What line parallel to one side of triangle divides the other two sides in the same proportion. Or if you want to say this, we say the proportionality theorem. The proportionality theorem, due to the fact that AB is parallel to DS, AB parallel to DS is a given fact. The next thing is, we know that RB over BS is DC over CS, which is 5/3. So this means that here we can write AR over AD, but it is RB over BS, and RB over BS is 5/3. So what is AR? What is AR? AR is equal to, AR is 48 minus AD. If I want to find AR, I can just say the whole of 48 minus AD, then I'm going to get AR. If I want to find AR, I repeat, I want to find AR, I can just say 48 minus AD. So AR here is actually 48 minus AD. We divide everything by AD, which is 5 out of 3. Cross multiply this. If you cross multiply this, it means that we have 3 times 48. 3 times 48 is 144 minus 3D, 3AD, which is 5AD. So move this across, you have 144 is equal to 8AD. You divide through AD, which is 8, which is 144 out of 8. And this means AD is 144 out of 8, and 144 divided by 8 is 18. So AD is equal to 18. If 8 is equal to 18, what is AB? What is AB? Right, so this is 20 and this parallel to this and this, so this one becomes a parallelogram. And now having a parallelogram, so AB is equal to 20. Which means the opposite sides of palm, opposite sides of a parallelogram are equal. If this one is 20, it means therefore that also this AB is going to be 20 as well. Right. So hence, the ratio of AD to AB, the ratio of AD to AB, so what is AD? It's 18 and AB is 20. And so you divide these things by 2, you get 9 is to 10, which is what they wanted. They said, calculate giving reasons the ratio of the value of the ratio AD to AB. The ratio of AD to AB is 9 is to 10. Next question. Okay, in the diagram, O is the center of the circle ABCD. Use the diagram in the answer book to prove the theorem which states that the opposite angle of a cyclic quad are supplementary. That is proof that B plus D is 180 degrees. But to prove that one, you actually need to perform a construction like so. Okay, to perform a construction, you need to draw radii. OA and OC. And then after that, maybe we can write it anywhere, it doesn't matter. We can be able to do the proof now. Right, we can see that angle O1 is equals to twice angle B. Angle at center equals 2 times angle at circle. O2 is 2 times D. Angle at center equals 2 times angle at circumference. And then at this point, we can add O1 and O2. O1 and O2, which is 360 degrees. Okay, O1 and O2 is 360 degrees, and this, what this gives us is a revolution. Which means O1 is twice B. O2 is twice D, which is 360 degrees. Dividing through by 2, you have these, plus D. So obviously you add these two things now, and if you add these two things, you get B plus D equals 180 degrees, which is what we have to prove. So we've proven that using the diagram in the answer book. Well, we just use this one to prove the theorem, which states that the opposite angles of a cyclic quadrilateral are supplementary. That is, angle B plus angle D is actually 180 degrees, and we're done. Here's the proof. Please learn this one, because if this one does not come, then you have the 10 chord. If 10 chord does not come, then you have the angle at center is twice angle at circumference. Those are like the popular theorems you can meet. Okay, next question. Let's apply some of the geometry we've learned. In the diagram here, what do we have? In the diagram, DEFG is a cyclic quadrilateral such that EF is parallel to DG. H is another point on the circle such that DH is parallel to FG. Right, DH is parallel to FG. Chord EH, right, chord EH is drawn. Let angle D1 be equal to X. There it is, angle D1 be equal to X, there. Now, proof giving reasons that D1 is equal to D2. D1 is equal to D2 for 4 marks. Let's just prove this. Let's just prove this. Right, first things first, so it is obvious to see that angle EFG angle EFG, okay, because this is a cyclic quad, this here, so this angle plus this must be 180 degrees. D1 plus F must 180 degrees. So EFG is 180 degrees minus angle D1. Opposite angles of cyclic quad. All right, then you have EFG. The observation is therefore that angle EFG is 180 degrees minus D1x, like this. What is angle EFG? Angle EFG is also equal to 180 degrees. Angle EFG is also equal to 180 degrees minus angle G. So angle EFG is 180 minus G, because now you have the co-interior angles. This one and this one must give 180 because these lines are parallel. So which means that now this plus this must be 180, so that EFG is 180 minus G. And here, these are co-interior angles. The reason is that EF is parallel to DG. Right, obviously, if these two guys are equal to each other, because now you have EF, so the first EFG is the same as EFG, which is 180 degrees minus D1, which is 180 degrees minus G. Okay, but obviously this D1, we know that is 180 degrees minus X, 180 degrees minus G. So the 180 cancels out, meaning that we can be able to just be left with angle G is equal to X. But angle G is equal to angle D2. Angle G is equal to angle D2 because now you have alternate angles. So this angle is equal to this one. Okay, these are alternate angles. DH is parallel to FG. Which means angle D1 is equal to angle D2. Angle D1 is equal to angle D2, which equals X. Angle D1 is equal to angle D2 because you can see that D2 is G, but also you can see that G is X. Right, so you can see that angle G is X, and also that is X. And so, but you can also see that angle G is equal to angle D2, which means D2 is also X. The reason, therefore, you can see that D1 equals D2 equals X. So we had to just to show that D1 is equal to D2, and we've proven that for 4 marks. Next question, question 10. So this is the question just proven. This is the question we've just done for 4 marks. Right, so we have question 10 right now in the diagram. TR is the diameter of the circle. We have TR is actually diameter of the circle passed through the center. PRKT is a cyclic chord. So you have PRKT is a cyclic chord. Chords TP and KR are produced to intersect at S. Chords TP and KR. TP and KR are produced to meet at S. Chord PK is drawn such that PK is parallel to TK. PK is parallel to TK, or rather PK is equal to TK. PK is equal to TK. They're equal. Proof giving reasons. This is the last question in the exam. So proof giving reasons that SR is the diameter of a circle passing through points S, P, and R. Let's look at that one very quickly. In 10.1.1, prove that SR is the diameter of the circle passing through points S, P, and R. SR a diameter. SR a diameter of the circle passing through the points S, P, and R. S, P, and R. All right, so obviously, let's look at 10.1.1. TPR. Okay, let's look at TPR, for example. Now, angle TPR is equal to 90 degrees because this one is the center of the circle and therefore it obtains an angle of 90 degrees at circumference. In mathematics, if there is a diameter, it always obtains an angle of 90 degrees at circumference so that TPR is 90 degrees. And this is the case because you have the angle in semicircle. So which means this angle is 90 degrees, but also SPR. Angle SPR. SPR is also equal to 90 degrees. The angles on a straight line. Okay, you can see that SPR is also 90 degrees. The angles on a straight line, because if you add 90 plus 90, you must get 180 on the straight line. Well, the conclusion, therefore, is that SR is a diameter. The conclusion, therefore, is that SR is a diameter. SR is a diameter. It is the converse angle in semicircle. Okay. Because if you look at SR from here to there, it obtains an angle of 90 degrees there, which means it is a diameter. So converse of converse angle in semicircle theorem. So because now this one obtains an angle of 90 degrees there, it means it is a diameter. Next is to prove that 10.1.2, you need to prove that angle S is equal to angle P2. Angle S is equal to angle P2. Ten point 1.2. So you'd have that angle S is equal to angle P2. So to prove that, we were required to prove that angle S is equal to the angle P2 is the question. Is the question that angle S is equal to the angle P2. Now, if angle S is equal to the angle P2, we need to prove this. Right, the proof of that is obvious. We start by making the observation that angle R1 right, so angle R1 is equal to angle PTK. R1 is equal to PTK. So there's a theorem in mathematics that says if you have a cyclic quad like this, with all the vertices on the circumference of the circle, an angle that is here is equal to angle that is there. The exterior angle is equal to the interior opposite in a cyclic quad. So it's the same thing here. So we have R1 is equal to this angle there. And also you can say this angle must actually be the same, equal to that angle there. So same thing. So you have that angle R1 is equal to PTK. The exterior angle of cyclic quad. The exterior angle of cyclic quad equals the interior opposite. Angle P1, PTK. You have P1 is equal to PTK. So you have angle P1 is equal to PTK. Right, angle P1 is equal to PTK because this is an isosceles triangle. In mathematics, if you have this side equals this, if in this angle is equal to this. So because this side is equal to this side, then it means that this angle is equal to this angle. So angle P1 is equal to PTK because we have an isosceles triangle. And the reason for that, we say that the angles opposite equal sides. Next, we have that angle S plus angle R1. Angle S plus angle R1. Angle S plus angle R1 is equal to angle P1 plus angle P2. Angle S plus angle R1 is equal to angle P1 plus angle P2. S plus R1 is therefore equal to which is S plus R1. You can add S plus R1 is equals to P1 because plus P2 because this P1 is PTK. But now R1 is also PTK. So in the place of R1, you put P1. S is P2. So we just have combined these equations. We're adding S together with R1. So if you add S with R1, S with R1 is like P2 plus PTK, but PTK is P1. Make that observation. And therefore, if this is the case now, what is the conclusion here? Angle R1 is equals to angle P1 because they're both equal to PTK. So R1 is PTK, P1 is PTK, which means that R1 is P1 and therefore they cancel each other. And then it means that angle S is equal to angle P2. The reason for that is angle R1 is equal to angle P1. Like this. Next, Right, so we have 10.1.3, which is triangle SPK is similar to, so we've proven that S is P2. So we're done with this one and we're done with that one. Next, we need to prove the fact that these two triangles are similar, the similarity. 10.1.3, how do you prove the similarity of those triangles? So that is very, very straightforward. Let's just do 10.1.3 next to the shape. Right, so in 10.1.3, we need to just prove that triangle SPK. Let's look at triangle SPK and PRK. SPK. SPK, SPK, PRK, PRK, SPK, PRK. We need to prove that, but obviously SPK, PRK, both of them have K2 as a common angle. So we have a common angle. Right. We have a common angle. So we're going to say 10.1.3. In triangle. SPK. In triangle. PRK. Triangle SPK. And triangle PRK. Angle S equals angle P2. Angle S equals angle P2. Angle S equals angle P2 because we're looking at PRK. Angle S is P2. We've already proven that S is P2. Angle S is equal to P2. This one has been proved. It has been proved. What about angle K2? Angle K2 is equal to K2 because it's a common angle. It's a common angle in the triangle PRK and also in PSK or SPK. So if you look at SPK, it has K2. But also if you look at PRK, it has also K2. So in other words, we then say that angle K2 equals K2. Common. Now, if you look at the triangle SPK, SPK together with PRK, SPK, SPK and PRK. Okay. Okay, then you have a third angle now. Because you've seen that this one is a common angle. We've seen that P2 is equal to S. What angle is remaining? The third angle is actually PRK and KPS, or like SPK. SPK is PRK. Which is the sum of angles in triangle. So now we have the three angles here. This one, and that one that are equal in the respective triangles. So that means therefore SPK is actually similar to triangle PRK. And these are angle, angle, angle. Angle, angle, angle. So in other words, we've proven this one here that SPK is similar to triangle PRK. Last but not least, if it is further given that SR is equal to RK, SR is equals to RK. Let's check SR. SR is equal to RK. So this one here, SR is equal to RK. This SR is equal to RK. So if SR is equal to RK, you need to prove this here. Okay, we're going to start by saying we know this. Triangle SPK is similar to triangle PRK. Goodness me. Okay, we're back. This has been proved in 10.1.3 above. Okay, we proved the above that SPK is similar to PRK. And so at this point, it means you can take the first two must be equal to the first two, which is SP over PR. PK over RK, which is SK over PK. Okay, like that. So let's take this one with that one. So we're taking okay, you have this one, PK. And then now you can cross multiply these. If you cross multiply these, PK times PK gives us PK squared is equal to SK times RK. SK times RK. Okay, we continue now to the left of this. So, but if you look very carefully at ST squared, ST squared, ST squared, ST squared is equal to SK squared plus TK squared. There is some Pythagoras theorem because of the fact that this one is a diameter and therefore it obtains an angle of 90 degrees over there. And therefore it means that this ST is the hypotenuse of this triangle. So it means that if you look at this triangle very carefully, it is like this, right-angled triangle, so that this one is S, this one is T, and this one is K. So you have the ST squared is equal to SK squared and TK squared. So we write that one down. We write Pythagoras and say if we have this here, ESK which means it's ST squared is equal to SK squared plus TK squared. And the reason for this, it is Pythagoras. Okay. What is more? Okay, obviously this angle here is the right angle. So you just need to note that. But we also have that TK is equal to PK. Let's see. PK is equal to PK. Okay, they've given this marked, they're equal. TK is equal to PK. They even have said here, PK is equal to TK. So we have that PK is equal to TK, and that is what we need to write here. TK is equal to PK. Why? Because it was given like that. So if this is the case, we can write that ST squared is equal to SK squared plus, what is the TK? TK is PK squared. Which means ST squared is equal to ST squared is SK squared. But what is PK squared? PK squared is this. PK squared is this, which is SK plus RK. ST squared. What is SK? What is SK? SK can be seen different. Let's look at SK. Let's look at SK. These two guys are equal to each other. So which means that wherever there is SK, we can put double RK. Double RK. SK is double RK. SK becomes double RK. And then you square this. So what is SK? We've said SK is double RK. So you can put double RK times RK. And this means ST squared is equal to 6, because this is 4 RK squared plus 2 RK squared, which is 6 RK squared. And then now, if this is true, then you take the square root both sides. So this is ST. So which means ST squared, which is 6 RK squared, which means ST squared, which means you have RK here. So which means ST is a square root of 6 RK. And that's what they said you need to prove, that ST is a square root of 6 RK. That was the end of the exam paper. 100% obtained. Get this like that, 100% obtained. We've done all the questions. This is the end, because if you check, the next thing is just the formula sheet of the exam paper, and it's the end. Okay, so we have done the least squares regression line using a calculator. We've done the mean using a calculator. We've done the standard deviation using a calculator. Yeah. So guys, we are done. So what I'm gonna do now, I'm gonna pause the video and we'll talk. I might offer a lesson maybe at 3 or 4 in the morning. Maybe we're gonna be having load shedding. Okay, but yeah, most of the guys here are okay. So it's important Senulo are around the Soweto, but obviously I have Ayanda. Ayanda might be from Val, you know. I was just given Ayanda by one examiner, might be from the Val area. So their load shedding program is different, or schedule is different from ours. Let me just post this video. I'm gonna send another message after I posted the videos, the 3 videos, and then I'm gonna post one video that combines all of them. But that one takes time because I'm gonna combine the video of the morning, this video, so that we form one video that is continuous, that has like everything in one video. All the discussions from beginning to the end will take a couple of minutes to be combined. But yeah, I'm gonna send you the links to the videos. And then I must thank you guys for joining us for now. I think we need to take a break. I can return back again at around 3 a.m. because if I look at the load shedding schedule, let me see what is going to be happening at 3. Maybe we're going to be having no power. Because see, if the power is not there, then I can do the lessons, but the network is not so good. And if the network is not so good, then it's going to create some problems. Okay, yeah, you see, there's going to be load shedding from 2 in the morning until 4. So it means that if I want to come back, I can only come back from 4:30 in the morning, which is fair enough. 4:30 you'll be waking up. So I think I can send you messages at that time and you're going to decide what to do, because then I can wake up and do something and just look at some exam predictions to say, this, you need to put your thumb on. Like what I was saying, you can put your thumb on what? The circle theorems. If it's not the opposite angles of a cyclic quad, if it's not the opposite angles of a cyclic quad like this, they ask the opposite angles of a cyclic quad are supplementary. So if it's not that, they can ask you to do they can ask you to do Tenko theorem to prove it. If it's not Tenko theorem, they can say angle at center is twice angle at circumference, you know, that kind of thing. So you can like pinpoint those and make sure that those 3 you know very well. One, you know the 3 proofs. If you this one you can prove it, or you can prove the angle at center is twice angle at circumference, or you can prove the Cherenkov theorem. If you can prove those 3, then I'm sure that you would be very safe. Okay, I must thank you guys for joining us. I'm going to send you again a message. I think I'm going to check you again at 4:30 a.m. when you're waking up. Maybe we can do something for a few minutes before you bath. I don't know. Yeah, but I'm going to check on you. Thank you guys. Goodbye, Tsenulo and Mpo. Goodbye, guys.
Bye.
Goodbye, Mpo. Goodbye.